G'day, a very good day to you. I'm Dr. Philip Button, and I'm in the Royal Botanic Gardens in Melbourne, which were established in 1846 in a very shady spot on this warm, sunny summer day. And it's just a fabulous garden here, and highly recommend it if you're visiting Melbourne to come and take a look and enjoy these absolutely marvelous surroundings. And even though it's a weekend, it's a Saturday, and it's warm and sunny, and there's plenty of people out, there are still opportunities to have seats for in the shade, in the sun, or with a view, or where I'm at here in a lovely shady spot where there's just trees all around, and it's just really nice. So highly recommend popping by and adding this to your list of places to visit should you be in Melbourne anytime soon, or anytime at all, really, of course. Now, what I want to take you through in this video now is the fourth in our 5-part series on food safety and quality, so HACCP and GMP. And we're basically up to the biological hazards part, where I want to go through the bacterial hazards. So going to share my screen, and then we shall get into it. Just bear with me while I share my screen, and then we shall be off and running. Off and running indeed. So there we go. Now just move a few things around on my screen, and there we go. So now we want to go into biological hazards. So biological hazards, cover all of the microorganisms. So we're talking about yeast and molds as fungi, bacteria, and viruses, and the eukaryotic protozoa as well. And of course, it includes parasitic worms, which are of course animals. But all of these are included in what is regarded as biological hazards from the HACCP perspective. Now, with spoilage and pathogenic microorganisms, it's important to really have a distinction between the two, because a lot of people think that, okay, I've got a food product, it's you go to your fridge, you've got pasteurized milk there, you give it a bit of a sniff or a bit of a shake, and it doesn't smell right, and it's gone a bit lumpy, and people naturally think that it's unsafe. But first point there, most spoiled foods do not present a health hazard, and they're even though they do not appear normal, they're certainly safe to consume because they've been spoiled by spoilage microorganisms. So they're not the microorganisms that are going to pose a health risk. So, for example, the so-called off-pasteurized milk due to growth of psychotrophic Pseudomonas species is a typical example of that. Or in the case of UHT milk, for example, you can have the lumpiness, which is called age dilation, without any microbial growth at all. So it smells fine, it tastes fine, it's just gone lumpy because of the chemical reactions that have taken place. So by and large, virtually all food poisoning incidents occur with consumption of food that smells safe, appears safe, looks safe. Otherwise, if food was, obviously, going to make you sick, would people eat it? You'd say, highly unlikely. So food spoilage or decomposition that can result in a food safety problem should be prevented or controlled by a HACCP program. So that's, basically, what we're talking about in the context of HACCP or quality management systems, which are here, which are created to ensure that you have food that's of edible quality and that is safe. But the real take-home message that I want to get from this particular slide here is that there is really a distinction between spoilage microorganisms and food safety microorganisms, where those that spoil food and reduce its quality are almost never going to be going to pose a health hazard. So what is in raw milk? And I've gone through some of this previously in a previous video. So just going to skim this particular slide here, where and get on to the some actual tables on this. But there are really many spoilage microorganisms present with few pathogens. So that's important to remember that yes, there are a lot of microorganisms in milk, but yes, many of them are spoilage microorganisms with very few of food safety concern. But having said that, there are some that are still possible to be present, which are going to make you sick, and therefore it's a simple procedure to simply heat treat the milk, as opposed to drinking raw milk. So we've got Pseudomonas species, which interestingly may or may not dominate, but I'll get onto that in these upcoming slides here. So these are results from Malaysia, where these researchers looked at the presence of pathogens in raw milk, and you can see that in their 930 samples, there's a very substantial amount of pathogens present. So we've got, over a third had E. coli 0157H7, which is, one of the so-called, nastiest types of E. coli. And we're not just talking about, harmless commensal E. coli. We're talking about those that are the enterohemorrhagic, the ones that cause hemolytic uremic syndrome, and they were very prevalent in indeed between 29 and 39% in the different regions of Malaysia. Salmonella and Listeria in this study were much less prevalent, but what really is of concern is that E. coli, not just E. coli, but not just enterohemorrhagic E. coli, but E. coli 0157H7 was present at such a high prevalence. Remember, these are results from Malaysia, and now we've got some results here from the US, where you can see out of bulk tanks and out of that particular situation in bulk tanks, we've got a very low prevalence. So not sure whether that's the seasonality, or whether it's a location between Malaysia and the US, or there's different hygiene standards, or there's differences in methodology perhaps. But whatever the case, we've got a considerably less amount of E. coli, but interestingly, we've got much more salmonella out of the bulk, out of the raw milk from the bulk tanks. So there's differences there. I'm not sure what the differences are based on, but there's certainly differences between different places or different climates. But whatever the case, the main message from this is that pathogens are there. They are present. They might be present in much lower concentrations than spoilage microorganisms, but they are certainly still there. So in the coming slides, what I want to go through are some of the key species that are present. So we've got Campylobacter jejuni, which milk is one of the sources. So it's quite common from chicken meat and like poultry and poultry products. So chicken meat as well as eggs, but it can be found in milk. And it is, it does have a animal source, so environmental, some water sources as well, but both wild and domestic. And the thing to note, the point to note about Campylobacter jejuni is that it is the most common cause of foodborne disease. And certainly in Australia and in various other countries of the world, it's Campylobacter and Salmonella, which are the top two, but it's Campylobacter that generally edges out Salmonella in terms of the number of reported cases per year. So I've just mentioned Salmonella, and we've got Salmonella as the number 2 most prevalent cause of foodborne disease, so-called gastro, as a lot of people say. And similar but more extensive than Campylobacter, Salmonella is found in so many different environmental locations, almost ubiquitous, one would say, but it is definitely a animal source pathogen. So intestine of mammals, as well as birds and amphibians and reptiles, all these different types of animals from their intestinal region, but it is it does have animal sources, and it results in an infection, gastroenteritis, which has got typical symptoms of nausea and vomiting and abdominal pain and so on. And so as far as foods go, similar to Campylobacter, poultry and poultry products are probably regarded as the most important source. But having said that, dairy products as well, certainly important. But having said that, there's been outbreaks from all kinds of foods, chocolate, peanut butter, as well. But the dairy products remain an important source of salmonella infection. Now, Listeria monocytogenes is much less encountered, but it has a very high mortality rate, which is why it is so important, and which is the reason why pregnant women are advised against eating soft cheeses, because of the risk of acquisition of Listeria monocytogenes from dairy products, particularly soft cheeses. And with its high mortality rate of something like 25 to 30%, it's not a pathogen to play around with. And I've got there upwards, it can be close to 40% mortality in some situations. And interestingly, it's not just a gastrointestinal involvement, so it's also got neurological involvement. Meningitis as well as encephalitis as well. And it's even more ubiquitous than Campylobacter or Salmonella. So it's got a very wide range of environmental sources, animal and non-animal. Now, Chronobacter sakazakii is particularly involved with infections that are acquired from infant formulas, milk powders, but particularly infant formulas. And I've got the old name in there, Enterobacter sakazakii, because if you're looking for information on this microorganism, you'll quite still likely come across the old name of Enterobacter. But remember that the new name is Chronobacter. Species name stays the same as sakazakii. So again, animals and environmental sources, and I've also already said infant formula, but the disease characteristics are particularly particularly severe. So we've got meningitis, sepsis, and necrotizing enterocolitis as in infants, remember, as the disease characteristics of this particular microorganism. So particularly nasty, and it has a target group of the infants, babies. So pay particular attention to the presence of this microorganism in powdered milk products and infant formulas. And the last bacterium that I want to go through is Staphylococcus aureus. So Staph aureus is very widespread. So not only environmental, but particularly in people as well. And one of the favorite introductory practical classes for microbiology students is actually to sample their own nose for the presence of Staphylococcus aureus, because many people are natural, normal carriers of in their nostrils of Staph aureus. So that's one of the key reasons that it's important to not to sneeze when you're preparing food, not to blow your nose, and if you do, make sure you wash your hands and those sorts of things. So we're not just talking about COVID safe protocols here, but this is something that has been going on a long time. Nasal carriage of Staphylococcus aureus, which doesn't harm the people that's carrying it, but if it gets into food and other people acquire it, then it can be an opportunistic intoxication because of the staphylococcal enterotoxin. Yeah, dairy products, but a whole range of different food. Different food products, really, including dairy products, but human to human, or human to food to human transmission from nose and other body surfaces is particularly important. So what I wanted to do in this particular video was really to take you through the key bacterial pathogens, Campylobacter and Salmonella, as the ones which are most prevalent from the gastroenteritis perspective, but also Listeria monocytogenes, which is extremely significant but not as commonly encountered. Extremely significant because it's got a very high mortality, and then Staphylococcus aureus, which is very common and doesn't is a normal bacterium that is carried by people, but can cause opportunistic infections in others. And of course, we've got Chronobacter sakazakii, which is present in infant formula and targets babies and infants, and therefore is particularly important to take note of. So thanks very much for listening to this HACCP number 4 video. I look forward to you when I wrap it up with the session number 5. But thanks very much for joining. It's been a pleasure talking to you and taking us through these particular bacterial hazards, and I look forward to having your company during the next session, our 5th and final in our HACCP and GMP series on food safety and food quality. Thanks very much for listening, and a very good day and goodbye from the Royal Botanic Gardens in Melbourne. See you around. Bye.